Okay, the recording has started. So today we're on page 62, where it says, not 62, I'm lying. We're actually on page 52, right? Where it starts with differentiation of hyperbolic functions. Now, so the following are defined as the hyperbolic function, right? We have the hyperbolic function of sine x, and then the hyperbolic function of cos x, and it is defined as x e to the power of x minus e to the power of negative x over 2, and the hyperbolic function of cosine. The hyperbolic cosine of x is then defined as e to the power of x plus e to the power of negative x over 2. Now there on page 52, they say that the other hyperbolic functions are defined as follows. So then they show you that, for example, the hyperbolic function of 10, right? 10, the hyperbolic function of 10 is equals to the hyperbolic function of x over the hyperbolic function of, the hyperbolic function, the hyperbolic cosine of x. Sorry. The hyperbolic 10 of x is equals to the hyperbolic sine of x over the hyperbolic cos of x. Some people call it sinh, some people call it cosh, right? So now on activity 1 day, they want you to find from number 1 to 6, they want you to find the hyperbolic function of cos 3x. So meaning that you can use, what's this? You can use the definition of these two to find the remaining hyperbolic function. Are we all together there?
Yes.
Yeah. So let's look at this one. So they want us to find, let's do one example in activity 1. So they want us to find the hyperbolic cos function, the hyperbolic cosine of 3x. So the hyperbolic cosine of 3x, meaning cos 3x. Now, we know that the hyperbolic cosine of x, the hyperbolic cosine, which is cos of x, is equals to e to the power of x plus e to the power of negative x over 2. Meaning that here, where we see x, we'll put what? We'll put 3x. So the hyperbolic cosine of 3x will then be equals to e to the power of 3x plus e to the power of negative 3x over 2. So then you can go and do activity 1. If you have a problem, then you can send me the problem, then we can work on it. Are we together? Are we together, yes or no?
Yes, ma'am. Yes.
Now, on page 53, they're just showing you that there are certain identities of the trigonometric functions. Remember, so since then we have the identities of a trigonometric function, right? We also have identities for hyperbolic function. For example, remember we had sine squared of x plus cos squared of x is equals to 1. Meaning that the corresponding, or something that looks more similar for a hyperbolic function, will be cos squared of x minus sin squared of x is equals to 1. And one of the identities, if we can just write them, is if we have, what's this? If we have sec squared x equals to 1 plus 10 squared x, meaning that when it comes to hyperbolic function, we have that 1 minus the hyperbolic 10 squared of x is equals to the hyperbolic sec squared of x. So there is some form of similarities if you look at the two. So make sure you just go through the tables on the table on page 53. I will not ask you in the exam to draw these hyperbolic functions, which are on page 54, 55. But what I want you to do is just go through them, and then also go through the range, the domain, and everything that is on page, those tables on page 54 and page 55. Are we together?
Yes, ma'am.
Yes, ma'am. Yes. Yes,
So
ma'am.
now let's go straight to differentiation of hyperbolic functions. Now they say the derivative of hyperbolic sine x, hyperbolic cos x, and hyperbolic of tan x are easily found from the exponential definition. Remember, we said that we have y is equals to hyperbolic of x. We know that this is defined by e to the power of x minus e to the power of negative x, right? And we have that, oh, sorry, let me not say y. Let me just write it like this, over 2. And we have that the hyperbolic function, the hyperbolic of cosine x, is defined by e to the power of x minus e to the power of negative x over 2. This is a plus for cos. So they are saying that for you to be able to find the derivative of these particular functions, what happened is you just look at, what's this? You just look at the exponential definition and then differentiate. Let's differentiate the hyperbolic sine of x and see what we get. So if we have y is equals to e to the power of x minus e to the power of minus x over 2. We know we can write this as 1 over 2 e to the power of x minus 1 over 2 e to the power of negative x. Now dy over dx is equals to this. We know that the derivative of e to the power of x, so dy over dx of e to the power of x is just e to the power of x multiplied by this derivative. So this is 1, so this is just e to the power of x. So then it means we have 1 over 2 e to the power of x minus 1 over 2 e to the power of x multiplied by the derivative of this function. In this case, it's what? It's minus 1. So then this will be equals to 1 over 2 e to the power of x plus 1 over 2 e to the power of minus x. Now, if we write this properly, like this, e to the power of x plus e to the power of minus x over 2, you'll notice that this is actually cos, the hyperbolic cosine of x, which is cos of x. Do you see how we derive them, guys?
Yes, ma'am.
Thank you. So now on page 56, they are giving you the definitions, right? In your exam, you'll be given the definitions, but it's important that you understand them. So I noticed your previous exam, last year's exam, which we'll also attempt before our final exam, they gave you the tables. So now, but then it's important, imagine being given a table and you don't know how to interpret it. So it's important that you're able to interpret it. So they're saying, on page 56, they're saying, following a list of derivatives of the hyperbolic functions. Now, since, or the hyperbolic function of f of x, the derivative, so this is the function, and these are the derivatives. So they're saying that since the hyperbolic function, the hyperbolic sine of f of x is equals to the hyperbolic cos of f of x times the inner function, the derivative of the inner function. Are we together? Now, the hyperbolic function of cos, if you're given the hyperbolic function of cos of f of x and you're asked to find the derivative, then this will be the hyperbolic sine of f of x times the derivative of f of x. Now remember, when we had cos, right? When we had cos of f of x and we find the derivative of cos of f of, we had negative sine of what? We had negative sine of f of x times f of x. Now, you should be careful that you don't do a mistake when it comes to hyperbolic function and put a negative sign there. Are we all together?
Yes, ma'am.
Yes, ma'am.
So meaning that we can then go through the entire table there, and therefore it can be able to help us solve the following problems. So I think we'll do the 2 examples and then we go to the next question. I mean the next work. So now we have y is equals to the hyperbolic sine of x squared, right? The hyperbolic, okay, let's say sinh squared x, and you're asked to find the dy over dx. Can someone help me there? Let's try, guys. Someone help, please.
Are we not gonna write it as sinh hx in brackets, then we put the 2 as an exponent outside?
Thank you. So let's write it like that. This will be the hyperbolic sine of x squared. Then
we have our do we not take the 2 to the front?
Okay, so that now we are differentiating dy over dx is equals to 2. Then
do we not keep this sinh, then then derive the sinh as a hyperbolic cos.
Thank you. So it's 2 minus 1 times the derivative of sinh, which is cos, or the hyperbolic cosine of x. So in this case, it'll be cos of what? Cos of x. Okay, let me write it properly. So this will be cos of x. So this would then be equals to 2 sinh of x times cos of x. Are we all together there, guys?
Yes.
Yes, ma'am.
Yes, ma'am.
And just notice that the more you practice, right, especially with the activities, the first problem on activity 1 or post-test 1, it will be easier compared to the last one. So what you're doing is, the more you start from the beginning and continue and doing all of them, you are learning some skills. So meaning that later on, it will be easier for you to do more difficult questions. But if you still don't understand a question and you have attempted it and you're not getting the answer, please send me an email. I'll record it for you. Are we together?
Yes, ma'am.
Thank you. So let's go to example 2. Are we okay with the green color?
Yes, ma'am.
So example 2. Now example 2, we have y is equals to sinh of 2x times cos of 3x. And you're asked to find dy over dx. Now, we see that this is a product of 2 functions, meaning that we have to apply the product rule. It's a product of this particular function and that particular function. So dy over dx will be the derivative of this function, which is cos of 2x, multiply the inside function, which is what? Which is 2, multiplied by the derivative of the inside function, which is what? Which is 2, times cos of 3. So we are done with the first function. Now we add and differentiate the second function. So we leave the first function the way it is. So that is sinh of 2x times the derivative of this function here. So we know that the derivative there will be what? The derivative there will be sinh of 3x times the derivative of the inside function, which is 3. So then this will be equals to 2 cos of 2x times cos of 3x plus 3 sinh of 2x times sinh of 3x. Are we all together there?
Yes, ma'am.
Yes.
Thank you. So you can go through those questions. If you have a problem, do not hesitate to send me an email, then I'll record it for you. Now let's go to inverse of hyperbolic function, right? Which is on page 61. Guys, do you remember the inverse of a function? I think we didn't go through that. Do you remember what is the inverse of a function? What happens before you find the inverse of function? You're given a function, then you have to do what? Then to find the inverse of function, or you just find the inverse of function? Guys? Hello? And why are you quiet today? Why are you quiet, guys? What is the inverse of a function? If you say find the inverse of, what are you finding exactly? Do we remember, or we don't remember, or we're just going to keep quiet?
I don't remember.
Isn't it functions that reverse each other?
Reverse how? Reverse how? Okay. Let me remind you then. Now, remember we had what we call a vertical line test, right? If you draw a graph like this, this is a parabola. We all know it's a function. Now, if we take a vertical line like this, and it cuts the graph once, then we say it's a function. Isn't that what we say? Guys?
Yes, ma'am.
Now, then there's a horizontal. After testing that this is a function, we had what we call the horizontal line. What does the horizontal line test? They said, okay, we have a horizontal line, and we say that if the horizontal line cuts the particular graph once, then we say the function is 1-to-1. So in this case, is this function a 1-to-1?
No.
Then it's not a 1-to-1. That is why in grade 12, we were restricting our graphs and then say, okay, fine, we'll restrict this graph such that it becomes 1-to-1. Instead of drawing the whole parabola, what we did was we actually cut half of it. It's either we drew this one or we drew the other. Do you remember that one?
Yes, ma'am.
Then we were asked to find the inverse of a function, meaning that we had y is equals to x squared, right? And then we interchanged y and then interchanged x. So then we have y is equals, so we had x is equals to y squared. And then after that, we write y as the subject of the formula. And then we had that y is equals to plus or minus square root of x. And then we were able to grow a graph, whether the graph was like this, right? Or the graph was like that, depending on which part of the parabola you cut. Or the graph was like this, and then you had y is equals to square root of x. Do you remember that?
Yes, ma'am.
So then you're finding the inverse of a function. Now, here, when they say the inverse of a hyperbolic function, they are saying the same thing of saying, okay, fine, you know that the hyperbolic function is a what? Is a 1-to, it's a function, and then it's also 1-to-1. Therefore, you are finding the inverse. That's what they're explaining there on page 62. They say interchange y and x, then write y the subject of the formula and whatsoever. Then you find what you call the arc hyperbolic function of cosine or the arctangle, the arcsinge, the arccosh. Are we all together there?
Yes, ma'am.
3 yeses, then I move.
Yes, ma'am.
So now, there's one property that you need to know is that when you're talking about, I don't know if you remember composition functions, if you have done composition functions. Do you remember composition function? Where you have a function f of x, and we talked about composition function, where the function f of x, let's say it's cos of x, and then you have let's say g of x, sorry. Then you have g of x is equals to x squared. Okay, let's say 3x. Remember when I said composition function, it means you're taking one function and putting it inside another function. So meaning that this will be cos of g of x, then this is equals to cos of 3 of x. We talked about this in the first session. Do you remember that? Yes, no?
Yes, ma'am.
Yes,
Good.
ma'am.
So now there's a rule that says if you take the composition of the function and the inverse of that function, then this will be equals to x. Or if you take the, the composition still, where the f of x now is inside, you still get what? You still get x. Do you see that? Are we all together there, guys?
Yes, ma'am.
Good. So now that is why when we go to, we remember when we have an exponential function, x, right? Or any exponential function. What was the inverse of that exponential function? If you remember. What was the inverse of the exponential function? In this case, let's say e to the power of x. What was the inverse of that? If you remember properly. In your grade 12 work, what was the inverse of any exponential function? It was a log function, right? So meaning that if you take the inverse of this function here, you'll get that y is equals to ln of x. Now, if we apply the composition where we said if we take the composition of the inverse of a function and the function itself, then we get x. Meaning that if I take ln of e of x, then I'll get what? I'll get x. If I take e of ln of x, then I'll still get what? I'll still get x as well. Are we all together there?
Yes, ma'am.
Thank you.
Yes, ma'am.
Now, if we go back to page 62, you notice that when we were defining sinh, for example, sinh or the hyperbolic sign of x, we said e to the power of x minus e to the power of negative x over what? Over 2. So it does make sense when we say that the arcsinh or the inverse of the hyperbolic sign of f of what's this? Of x should be a ln function, because we know that if we have an exponential function and you find the inverse, then you'll get what? A log function. So meaning that what is on page 64, the arcsinh or the inverse of the hyperbolic sign of x should be ln of x plus the square root of x squared plus 1. Now, here they're defining the domain where x should be between what? Negative infinity and infinity. Are we all together there? Let's just write it like this. Are we together there? Guys?
Yes, ma'am.
Thank you. So now, let's go to solve for x. They say we have arcsinh of x is equals to ln of 2. How do you think you'll solve that? Can someone tell me? Write it nicely. They say solve for x. Now you have arc sin is equals to ln of 2. How are you going to solve for x? Guys, how are you going to solve for x? Can you please try? Is there anyone trying today? What's going on? The energy is very low today, guys. What's going on?
Ma'am, are we
Sorry,
not?
ma'am, I've just joined, so I'm lost on. I'm still trying to find my grip, so that's why I seem like you find a lot.
Okay. Okay, I understand that's the first one. And then what's another reason for those who haven't just joined?
Mina miss, I'm at work, so I'm trying to be in class while still trying to catch things on the other side. So,
Okay. Thank you very much. And then the other people who are not at work. Guys. Hello?
Yes, ma'am.
What's going on? Are you lost completely? Or what's going on?
I was about to try, but then I let the others have a chance to speak.
Okay, please speak then.
Okay. So solving for x, for that arc hyperbolic sine x, are we not going to use that formula that they gave us, which is ln x plus the square root of x squared plus 1?
Why are you using that? Why are you using that?
Isn't that the defined exponential functions term?
Are you always going to use that? Because I don't want you in the exam, you put it in there and then you don't know what to do. Do you understand? Because
Hello,
now,
ma'am.
yes.
Oh, you can go ahead. I will just chip in when you are.
Okay, thank you. In the exam, I don't want you to just apply it because, okay, now you can see space 62 and then it's there and then you define and you can place it. But in the exam, I want you to understand because what happened in the exam is a combination of everything. And once it's a combination of everything, then what's this? And once it's a combination of everything, then we might have a problem of identifying if you are unable to start identifying now. You need to know why you are doing it. Can you please chip in? Okay, okay, answer then. The person who said they'll chip in, can please they come in after you? You
Okay.
say?
Okay, ma'am. We are
Okay, can
given
we allow
the.
the lady first? I just wanted to explain the part and then you chip in.
Okay, ma'am.
Thank you. Yes? You're saying?
I was saying, are we not using that because they said we must solve for x and we are not differentiating?
Okay. And then chip in, please.
Okay, thank you, ma'am. The arc sign of x, we are given its function expressed in logarithmic terms.
Yes.
So I will replace the arc sign of x with with its logarithmic function. Then
Yes.
on this side, then that's where I'm gonna use that ln of x plus x squared plus 1 in the square root.
Okay, now you both correct. Why are you doing that?
I am doing that because once I substitute the arc sine of x with its with the term, the expression that carries the ln, then all functions carries the ln of the something whereby I gonna be able to cancel out the ln and solve for x.
Okay, solve for x. There's another one. Solve for x on that one.
As for this one, ma'am, can I try?
Try.
As for this one, I will solve what is inside the brackets, the arc sine for x, whereby I will replace it with that expression, whereby on the expression I'm gonna put inside, I'll put sine ln of x, the one you are writing, but with a 4. There's a 4 inside, right?
Okay, there's a 4. Okay, let's write that. So you're saying ln of 4x plus, you're right, so there's a 4 inside. Yes.
Then you said it's equals to 8, right?
Yes, it's equals to 8.
Equals to 8. What else? What else? Let me see what I can solve. The sign, which means in the brackets, we call that, let's say it's f of x. Then I'm gonna express again using that formula of ex minus e to the power x over 2 outside to solve for
It's what cinch. Okay, so it's minus here. While he's still talking, can someone come in? And this is 2 marks, by the way, ne? I'm giving you 2 marks.
Okay. Have I guessed it the right way, ma'am?
So far, so good. Let's stop there. Can someone tell me something here? What are we doing wrong? Someone different. What are we doing wrong here? Hello, guys? Or try. What are we doing wrong? What do you think we are doing wrong?
Yeah, maybe to from my side.
Wait. I want someone else. What do you think we are doing wrong? Guys, please try. Because if you keep quiet, what we'll do is then I block everyone. And then I work with those who are only talking, you see? And then I delete the recording. Can you please try? You know me, I'm okay with try if you try, because when you try, then I can see, oh, this is where you're struggling. This is what you're struggling with. Okay, something. Okay, please try, guys. I need you to try. Yeah, my document is lost, but I need you to try. Let's try. Okay, let's open a new one. Let's try. Guys?
Yes, ma'am.
I want someone different to try. And that's how I'll be asking the questions, because I'll be the one asking the questions. Put some little bit of trick there. Okay. Can the last person try? Then I explain. If then we don't try and then we shut off the discussion class, because it's a discussion class, guys. It's not a recording. Me, I just want someone to try, whether you are right or whether you're wrong. At least if you are wrong, then you will see, oh, this is how I do it, but then you tried. You see. So maybe in the exam, if you do, you might get some few marks than leaving the space blank. You never know. So try. Guys, I think maybe we should stop the recording, isn't it? Because I'm not hearing you try. So can you try? The first one was right. We replaced that Y. The second one, I'm saying it's 2 marks. So it means that you need to look at the question. Why? Or let me say 1 mark. Because the gentleman answering, he was fine answering, you will answer, but let's say 1 mark. Would you get that question in 1 mark now? And please try. It should give you, that mark should give you a clue. The first one, why are we using okay, let's call it arcsinh of x is equals to, let me write it properly here. So it's arcsinh of x is equals to ln of x plus square root of x squared plus 1. Let's try, guys. We still have a lot of work to do. Let's be kids like kids from crash. You ask them, this is what fruit? They say it's a banana when it's an apple. At least they've tried. Then you can see they're participating. So what do you think?
Have you added the third one? Is it the one which you say we need to try, confirm?
No, this one is the definition that you guys said we substitute in the first one, this one, right? And then you went and substituted in the second one here. But I'm saying I'm giving you 1 mark there. Can someone else try, guys, and then I continue? Can someone try and say, here I'm using this definition, here I'm not using this definition. Reason being, here it's like this and here it's like that. Whether you're right or wrong, then I'll explain it.
We demand the blues.
There shouldn't be Monday blues. It's Tuesday today. It's Tuesday. Drink a lot of water. Guys, are you lost?
That from Monday.
Guys,
I mean, Miss, honestly, I'm lost because I'm juggling between the two. I'm working at the same time. I'm trying to study with you all. So I get lost in some of the explanations.
okay, I'll let you go for now. And then, guys, the other ones, are you lost? What's going on? The others, tell me what's going on. Or you're confused?
Oh, I'm just trying to find the mistake, but I can't really find anything. Like, I'm really trying, and I don't know where.
So, Mandy, so you're the one who answered that previous question?
No, it's not.
Okay. So the other person? Who answered first? The lady who answered first?
That's me, it's Zintle.
So Zintle, you say that you substitute ln x there. Why did you substitute ln x? Because of the definition. But then now I'm giving you another problem that doesn't have ln x. And I'm saying that if you substitute ln x, it's wrong. It's not wrong, but I'm giving you 1 mark, so you can't do 7 steps for 1 mark.
Yeah, I think that's what's really confusing at this point. Yes.
Okay, so
'Cause
let's go. Yes, cause?
Oh no, I was just saying because I was like really trying to think how to go about it, since you said you get 1 mark, and obviously it doesn't make sense for us to have like 7 steps for just 1 mark.
Good. Were you guys listening since I started?
Yes, ma'am.
It means that you were listening, but not listening carefully. I want you to listen carefully now. Okay, so here, if you look at this arc hyperbolic of sine of x is equals to ln. For this point, it was easy to see that here you have to substitute this ln because you have some form of a ln here, right?
Yes, ma'am.
So that is why
Yes.
then it will make more sense to substitute that definition. So let's do that. So this is ln of x plus square root of x squared plus 1 is equals to ln of 2. Now, after this point, what did we learn? What are we supposed to do here?
We take out the ln and we are left with the what's in the bracket and 2. Yeah, 2. What's
Why are
in
you
the
taking
bracket?
out the ln? Why are you taking out the ln?
Let's say I'll divide each expression with ln, since I have ln on both sides to cancel for me to be left with only 1, because ln will cancel each other.
You see? Now you have sine x and you have cos sine 2x. Are you telling me you're going to divide by sine both sides? So that you remain with x.
Yes, ma'am.
Divide by sine. Guys, you need to be very careful. Divide by sine. Because that's how ln is acting on this inside function there. They did not write it in your textbook, but divide by sine. And remember that in the study guide, remember that the questions will be the tricks that we are doing right now. The questions in the exam will be the tricks that we are doing right now. But if you don't remember, then it's a problem. We said ln is an inverse of which function? Can someone remind me? We said ln is an inverse of which function? Guys?
E to the power x.
Yeah, to
Thank
the
you.
2 parts.
Thank you. So we say if f of x is equals to e to the power of x, then the inverse of f of x is equals to what? Ln of x. Now, if we take the composition of the functions, meaning that take one function, put it inside, regardless of the order, then you get what? Then you get x. Meaning that if you take e and put ln of x, you'll get what? You'll get x. And if you take ln of x and put ex like this, then you get what? You get x. That is the rule of the inverse of the functions. Are we together?
Yes, ma'am.
Yes,
Meaning
ma'am.
Yes,
that
ma'am.
here, you're not going to divide by ln. Because what I made an example, sine x equals to 2x. Remember what you did when you wanted to find x. You say sine of what? Okay, let's not look at that one. Now, you want to remove this ln, and you want to remain with whatever is inside, meaning that you need to introduce the inverse somehow. So we said that e to the power of ln of x, we get what? We get x, isn't it?
Yes.
Because we know that this is a function and this is the inverse. The composition of the two gives us x. Meaning here we have to say e to the power of ln of x plus square root of x squared plus 1 equals to e to the power of ln of 2. Are we all together now?
Yes, ma'am.
Yes, ma'am.
Good. So then it means that now, because we know that e to the power of ln of x is just equals to x, so meaning that you remain with whatever is inside. So this is x plus square root of x squared plus 1 is equals to 2. Are we all together?
Yes, ma'am.
So then let's simplify that. So this is square root of x squared plus 1 is equals to x. Okay, let me just copy it because we know how to simplify there, all of us. So this is x squared plus 1 equals to 2 minus x squared. 2 minus squared. So then x squared plus 1, this is equals to 4 minus 4x plus x squared. So then we simplify, then we remain with 4x is equals to 3, and then we remain x is equals to 3 over 4. Are we all together on how they found it on page 62? Yes, guys, or no?
Yes.
Thank you. Now, okay, the question I asked you, I said, sinh of arc sinh of 4x is equals to 8. Can someone tell me what happens? Where do I move from here? Can someone try? Where do I move from here? 1 mark, 2 mark. Remember what we said. This is sinh, right? This is the
Yes,
inverse
ma'am.
of the function. So meaning the left-hand side will be equals to what? 4x equals to 8. Therefore, divide by 4, divide by 4. So x is equals to 8, 2. Did you see what I just did?
Yeah, but can
No,
you re-explain?
It's because I said if you take the function and inside that function you put the inverse of that function, then it will be equals to x. Or if you take the inverse of that function and put the function inside, you get x. So we know that this is sinh and this is the inverse of sinh. Therefore, you'll get what? The answer will just be 4x according to this rule.
Understood, ma'am. Loud
Thank
and
you.
clear.
So if I give you an expression like this in the exam, and I say to differentiate, and people start panicking without knowing that this is just 4x. So if you know your rules, then we are fine. Now, let's move to differentiating the inverse of a hyperbolic function. Now, on page 65, there's a table of functions. So there's a function and there's a derivative. So they are saying that if you have arc sinh of f of x, then the derivative is f prime of x over the square root of 1 plus f of x squared. Are we all together there?
Yes, ma'am.
Yes, ma'am.
So now all of them, so there's been an error on the inverse of the hyperbolic function of cot. Do you see that? The last one.
Yes.
There's an error there. So that will look exactly the same as the inverse of the hyperbolic function of 10.
See.
In the exam cheat sheet is corrected, but here, let's look at it and fix it there on your study guide if it's not fixed.
But here, ma'am, the one for arc cos, it have a -1, of which the one for arctan it have a +1.
Yes. So now there's an error there because the arc cos of a function, right? The derivative is the same as the arctan of a function.
Okay.
Yes. So please fix that.
Okay. So which means we have to say 1 minus the f of x squared inside the bracket.
Yes. Are you fixing that, guys? So meaning that the function is arc cos of f of x. Its derivative is 1 over 1 minus f of x squared times the derivative of f of x. Because I take in the answer sheet for the exam, it's fixed. But here there's some form of error. Okay, so it will be exactly the same as the inverse of the hyperbolic function of tan. Are we together there?
Yes, ma'am.
Thank you. Now on the same table, right? The inverse of the hyperbolic function of cosec, that is the arc cosec. Let's call it arc cosec. I hope they call it like that. The derivative there is -1 over absolute value of f of x square root of 1 plus f of x squared times the derivative of f of x. Are we all together?
So
Yes,
what
ma'am.
we just need to fix is just the absolute value of f of x.
Yes. So there, we're cosec. Let's say cosec. Yes. So there you have to fix the absolute value of f of x so that if you have, remember, if you have, let's say your f of x is equals to -2x, then the absolute value of f of x will be what? +2x.
Okay.
So there you have to
X.
put an absolute value there. Are you fixing those, guys?
Yes, ma'am.
Thank you very much. So then we can do, you see these sessions of derivative, they are nice because they're easier until you get to the hard ones. So let's do this one and then move to parametric and come back to the other exercises. Okay, so let's do example 2. Example 2. Now with example 2, you have y is equals to arc cos 2x, and they ask you to find dy over dx. So now, can you please tell me dy over dx of arc cos of a function is equals to what? Guys? According to the table. So it's 1 over
1 minus
1 minus
2x squared.
no, let's do the f of x first, the formula.
Yeah.
Squared times the derivative, isn't it? Yes.
Yes.
So now, meaning that from this one, let's write it here. So this is y of arc cos of 2 of x. Then from this one, you can see our f of x is what? It's 2x. Our f of prime of x is what? Is 2. So then let's go and substitute here. So then we have that dy over dx is equals to 1 over 1 minus f of x, that is 2x squared times the derivative, which is 2. So this is equals to 2 over 1 minus 4x squared. Do you see that? Now, example 2 shows that the table is incorrect because example 2 gives the correct answer. Do you see that? So it was just
Yes.
a human error there. Okay, before we go to example 3, do you have time to go to example 3? I want us to start with parametric, then we go back to examples. Is that okay?
It's okay, ma'am.
Thank you.
Okay, no problem.
So they say on parametric equation, that is on page 77, meaning that this week you have to have covered up to parametric equations, if not more. And all the exercises, are we together?
Yes, ma'am.
Thank you. In some cases, it is more convenient to represent the function. So they say it's more convenient to represent the function y off of x by expressing x and y separately in terms of a third independent variable called x. So they say sometimes it is more convenient, instead of writing y, we then write y is equals to a function of t and x is equals to a function of t. Let's call g of t, right? Whether it's basically they're saying a different variable compared to y and x. So that's what they're saying. So they say in some cases it is more convenient to represent a function y equals to f of x by expressing x and y separately in terms of the third independent variable, usually called t. So they say any value we give t will produce a pair of x and y. So meaning that if we choose t is equals to 3, then we'll get a y value of y value after substituting t and the x value after substituting t. Now they say that the third variable is called the parameter, meaning that this t is called what? The parameter. And the two expressions, y and x, are known as the parametric equation, meaning that this is a parameter, the t is the parameter, and these two equations are what? Are called the parametric equation. That's why we're calling this section differentiation of parametric equation. Are we all together? Why we are calling this section parametric equation, differentiation of parametric equation?
Yes, we are following, ma'am.
Thank you. So meaning that you'll be given two equations. You'll be given x is equals to something, y is equals to something. And that something will be, so for example, x is equals to theta and something, and then y will also be a function of theta. And then they will say differentiate. It means you have to differentiate parametrically using parametric equation, differentiation with parametric equation, because you are given two equations with a third independent parameter. Independent variable that we call a parameter. That's why we are doing parametric differentiation, differentiation of parametric equation. So now how do we do this differentiation of parametric equation? So they'll give you x and y, right? When they give you x and y, they will ask you to find dy over dx. Now, how do you find dy over dx? You know that x is a function of, let's say, time, right? Let's call g of t. And you know that y is a function of h of t, right? So what you go and do, you then, for you to find dy over dx, you first go differentiate, what's this? You first go differentiate y with respect to t, or differentiate both of them with respect to t. So this is dx over dt, meaning that this is prime of t. And then you go differentiate dy over dt. So this is h prime of t. Are we all together? So they are saying that for you to find dy over dx, this is the same as dy over dt times dt over dx. But in most cases, we don't like using this. Instead, we'll use dy over dt divided by dx over dt. Are we all together there?
Yes, ma'am.
Meaning that you say this divided by this to find dy dx. Are we together there?
Yes, ma'am.
Thank you.
Yes,
Because
ma'am.
dt over dx is just the same as 1 over
1 over
dx over dt. Now, according to successive differentiation, we said d squared, the second derivative of y with respect to x. What is it? It's the derivative. Can someone tell me? If we want to differentiate this, we went to dy over dx, isn't it? We went to dy over dx. To find the second derivative, we differentiated this with respect to x, isn't it?
Yes, ma'am.
Yes, ma'am.
But when you differentiated that with respect to x, it means your expression had some form of x, isn't it? That's why you were able to differentiate.
Yes.
Yes, ma'am.
So what we did, it means we took d of dx of dy over dx. That's what we did to find the second derivative. Now, with parametric equation, it's not easy to do this part here. Why? Because the dy over dx is not a function of x. So meaning that if I see you getting this answer and then differentiating the answer that you got with respect to x, then you are wrong trying to find this part over here. It's a mistake that most people are doing. I do not know why. That's why I'm emphasizing and highlighting it. Are we all together, guys?
Yes, ma'am.
Yes, why, ma'am?
Now, one person might ask, ma'am, you say, okay, fine. dy, I know from successive that the second derivative of y with respect to x is equal to the derivative of dy over dx with respect to x. But you're saying I cannot do this in parametric equations. How am I going to do it then? Because you say that I cannot take dy over dx and differentiate it to get the second derivative of y with respect to x. How am I going to do it? In parametric equation. This is how you're going to do it. You're going to take your dy over dx and differentiate it with respect to t, because this term over here, let me highlight it. This term over here is with respect to the other independent variable, meaning if we use t, it will be respect to t. If we use theta, it will be respect to theta. So you then take this y, dy over dx, and differentiate with respect to whatever variable. So in this case, it's the t. dy over dx, isn't it? Then you divide by dx over dt. Does it make sense, or we should go to the example? Maybe I explain everything that I just explained in the example.
We can try that.
Maybe.
Now, they're saying, okay, fine. You have, where's the question? Example 1. Okay, this pen. Example 1. In example 1, you have that y is equals to cos of 2x and t, sorry. If in the exam I write y is equals to cos of 2x and x, just know that the other variable is t. You see? You know, we make mistakes, and even when moderators check, sometimes the errors, you can't see them. You'll notice later. Do you see that now we have y and x, and we have a third independent variable there? Do you see that?
Yes.
So it means we're going to differentiate using differentiation of parametric equation. Now we're all together.
Yes, ma'am.
So I said, if now they ask you to find dy, so the question says find dy over dx and d squared y over dx squared, meaning the second derivative of dy over dx. Okay. Now, let's start here. We know that if, let's say, we have y is equals to 3x squared, ne? We know dy over dx is equals to 6x, isn't it, guys?
Yes, ma'am.
And we know that the second derivative of that is just the derivative of dy. In this case, is this one with respect to so you're differentiating this one with respect to x, so dy over dx, meaning that you're differentiating 6x with respect to x, and you got x. I mean 6. Are we all together on how we did it before?
Yes.
Can I have
Yes,
three
ma'am.
yeses? Guys, can I have 3 yeses, or am I losing people?
Oh, we're still
Yes,
here,
ma'am.
ma'am.
Okay, thank you.
Yes, ma'am.
So now here it's not, can someone tell me the derivative, if I have y is equals to sine x, I'm just trying to emphasize a point here. What is dy over dx?
Cos x.
Cos x.
Cos x. And then what is dy squared over, the second derivative is equals to?
Minus
Minus
sine.
sine x.
Thank you. With parametric equation, we're not going to do that. Let me explain why. Okay, so with parametric equation, dy over dx is equals to dy over dt times dt over dy. Now we know that dx. We know that dt over dx is the same as 1 over dx over dt. So we're going to use this, substitute in here. So this will be dy over dt times 1 over dx over dt. You don't have to derive that. I'm just deriving it quickly. So this means that this is dy over dt divided by dx over dt. Are we all together how I found it? So meaning that for you to find dy over dt, you're going to use this part over here. Are we together there?
Yes, ma'am.
So meaning that according to this part, we need to find dy over dt. So dy over dt, we go to y. Where's y? Y is this one. So this will be minus sine 2t times 2. Are we together there, or did I lose someone?
We're here, ma'am.
Together.
Thank you. Now divided by this one, dx over dt. So let's go and find x. X is this one, isn't it? So we want to differentiate dx over dt. So this is equals to cos of t. Are we all together then? Thank you.
Yes.
So now our formula says dy over dt, dx is equals to, where is it? This one over here, dy over dx, so that is minus 2 sine of 2t divided by dx over dt, that is cos of t. Are we all together there?
Yes, we're here, ma'am.
Now, can we leave it like this, guys? Can we leave it like that? What do you see? I want you to start seeing things in maths, not ghosts, but things like your identities, your ways of simplifying. What do you see?
Can we not change sine over cos into tan?
No. Why? You tell me.
Because the sign of a, let's say we have sine 2t at the bottom, we only have cos t, which we are looking. Oh,
Oh,
my English
okay.
minus 2.
Now I
We
understand.
don't have a 2 here. If we had
Yeah.
sine 2t over cos 2t, that's whereby we're
Yes.
going to say tan 2t.
Thank you. Tan of something, let's call something, the something is equals to always sine of something over cos of something. Meaning this something at the bottom has to be the same as the something at the top so that it gives that tan something. So we can't do that.
How about we take out the common factor?
Which one is that?
Minus, it's gonna be 2. Then we are left with o sine t, minus sine t.
No.
How did you remove? Whoa, wait. Hey, you played some magic there. How did you remove 2 and remain with sine t? I want to know. How did you do that? How did you do that? Because that's magic. Guys, I want you to look at, that's how fun maths is. If you learn everything, and this thing is in your textbooks, you want me to go and give you the page?
Ma'am,
Hello?
The double
Hello?
angle.
Oh, okay.
Thank you. And that is on page 532. 532. And it is number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Number 10 says sine, it's a double angle. Thank you very much. So sine of 2x is equals to 2 sine of x times cos of x. Meaning now we have sine of, meaning that we have sine of 2t. Give me the answer. Let's transpose. Give me the answer. That will be what?
2
Sine t minus cos t.
2
sine t
Sine t
times
and cos t.
I know someone is burning inside. Can that person who's burning inside help me?
It's not me. I'm not burning because I see something is wrong, but I just have a question. But there, what? I don't know. I'm lost, ma'am.
Okay, give me the burning. Why are you lost?
Can you explain something about this double angle and stuff?
So double angles are what you have learned in, remember when you're looking at trigonometry in your grade 10, 11, and 12. Okay, double angles are in grade 12. But you remember when you're looking at trigonometry, right?
Yes.
You had things called identities.
Yes.
So it's a rule, basically. You understand? So when you see it, you'll to simplify those trigonometric expression where you have to solve the left hand, show that the left hand side is equal to the right hand side. You were using things such as identities, the sine squared x plus cos x squared x is equals to 1. Tan of x is equals to sine of x over cos of. Do you remember those things?
Yes, I get that one.
Yes. So this one is it's those things when you're doing grade 12, and we should call them the double angle. And in your work, remember, I cannot teach you something that is not there. In your work, you are like, they even gave you a table on page 53. All the double angles. They gave you the double angles of sinh. They gave you the double of angle of cos. And you remember cos had like 3 of them, which you didn't even know which one to use. And then you just force the answer to be the left-hand side in grade 12, and then you get your marks. Do you remember that one? I'm taking you back. So if you open on page 53, you'll see those identities.
Okay. Thank you, ma'am. I get your point now.
Thank you very much. So meaning that we are going to use those identities here. So this is equals to minus 2 sine, sorry, not minus 2, what am I saying? Minus 2 brackets. Yo, guys, I've noticed people are not using brackets, and they'll start nicely and they'll keep on smiling because they think they are doing the right thing. And then they send me an email and say, ma'am, I am sure I got 80%. Why did I get this particular mark. It's because it's silly mistakes where you do. Here, we know that sine of 2, and there's a 2 outside. So take that 2 outside and put this inside. So this is 2 sine of t cos of t over cos of t. Are we all together?
Yes, ma'am.
Yes.
Yeah, I'm just taking you back to your grade 12s. And 10 and 11, 12. Remember when you're doing maths, it's not cram, pass, and forget. No. So this will then be equals to this cos, and that cos forms a 1. Some people will say they cancel. So sine of t. Are we right? Thank you. We are very right. Are we all together now?
Yeah, together,
Yes,
ma'am.
Thank you. Now, dy over dx, according to what we got, that is minus 4 sine t. Can we differentiate the way we were differentiating? Can someone give me d? The second derivative here. Please, fast, guys. What is the second derivative?
it's 4 cos t.
What is the second derivative?
It's minus 4 cos of t.
I'm going to pinch you. You know, you remember when they used to pinch us in under the arm? I'm going to pinch you. Those who answered minus 4 cos t, I'm going to pinch you. Is pinching a corporal punishment? No. I'm going to pinch you. Why? Can someone explain why? I said I'm going to pinch you. Can someone explain why?
Because of the negative.
I'm also going to pinch you. Not because of the negative. Why?
Because they have differentiated. They have differentiated with respect to x, but in a function of t.
Thank you. Thank you very much. Did you hear what she said?
Yes.
You have differentiated with respect to in a function of t. And I said, when you're doing parametric differentiation, you are not going to differentiate. The second derivative is not exactly what you did. So you need to do something else. Are we all together there now?
Yeah, I will get you, ma'am. Like we're supposed to divide by the derivative of that second function of dx over dt.
Thank you. Danko. So meaning that on that page 77, they are showing you whatever there. It's whatever I've explained. If you don't understand it as well, you can come back to the video. I said to you, and I hope you pinched yourself on my behalf. I said to you, if you're going to find the second derivative of, and you are dealing with parametric equation, you're not going to differentiate that function the way it is, because it is no longer with respect to x. It's with respect to the third independent variable. Guys, can you please mute? Can you please mute, guys? I'm explaining this part now. What is important is understanding your work, and then questions will come thereafter. As long as we understand, and I'm highlighting the mistakes that you guys are having. So now, it means that because you're like, no, I'm in parametric. I have two equations, therefore I cannot differentiate the way I differentiated. So I have to differentiate with respect to t of dy over dx. Are we all together? Are we together there?
Yes, ma'am.
After that, I divide by dx over dt. Do I have dx over dt?
Yes, ma'am, you do.
Thank you. Someone will say no, we do have. Okay, what was I was still on example 1. So our x was equals to sine of t, and we said our dx over dt is equals to what? Cos of t. So we do have dx. What we don't have is this one. How do you find this one? You take this one and then you differentiate with respect to t because it's a function of t, and you don't differentiate with respect to x like we did previously because we are under parametric. So then we have dy over dx. We know that is equals to minus 4 sine of t. So therefore, we differentiate this part. So we're looking for this part. This part will be d of dt of dy over dx. So in this case, that is d of dt of minus 4 sine t. Help me, what is the derivative there? The answer? Minus 4 cos.
Cos t.
Are we all together?
Yes, ma'am.
Then you take and go and substitute here. Okay, let's make space. Therefore, the second derivative of y with respect to x, this will be equals to d of dt of dy over dx over dx over dt is equals to, this part here is given by this part there. So this is minus 4 cos of t dy dx. What is this? Dy dx, where is it? Dx dy is cos of t.
It's cos of t.
So that is cos of t. Can we leave it like that, good people?
No.
Why?
Cos of t can divide each other.
Yes, they divide each other. Some people call it cancel. Form a 1. So that's the answer. Are we okay with parametric, guys? I won't see flames in the exam.
100% correct.
Thank you very much. As long as you understand your work, what matters is you understand your work. Okay, then we can move on. Let's do the second example. Now, when you're doing, the more you practice, the more it gives you more confidence, the more you can see tricks, the more you can do, because engineering maths, it's a lot of calculations, guys. You can easily do mistakes, you see. So the more you practice, I'm telling you, do 5 questions or give yourself 2 hours every day to do your engineering maths. And then, you see, you'll be fine. So let's do example 2, quick example. Example 2, that is on page 78. They say x is equals to 3, 1 minus cos of theta. Y is equals to 3 theta minus sine of theta. And they ask you to find dy over dx and d squared y over dx squared. What are we doing here, guys? Can someone explain what are we doing here? Like, don't tell me exactly, hey, divide this. Just tell me what are we doing? How's it different from the normal derivatives? That's it.
We are doing parametric equations.
Why?
Why? Because we have 2 functions, x and y, with what can I say? With the an extra, what can we say? With the third parametric, which is the cos or sine or
the
what?
theta. This one.
Yeah.
This one. Theta. It's called theta. Yes. So for dy dx squared, the second derivative of dy with respect to x, why is it not the same as the one we normally did in successive differentiation? Guys, why don't we differentiate? Why don't we get this directly from that? Can someone else give me an answer? We said why? Because
because we are not differentiating with respect to x, but with respect to the third parameter.
thank you. Because then dy over dx is with respect to the other parameter. It's with respect to the other parameter. So then if we differentiate directly, then we are incorrect because here we're looking at parametric equations. Are we all together?
Yes, ma'am.
Can I please have 4 yeses now because I see it's quiet.
We are burning.
Yes.
Yes,
Yeah.
I want the burning questions. Is there a burning question, guys? Is there a remember, when you're writing the exam, you're writing alone with the invigilation app. So it's 2 of you guys. Then me, I'll be looking, you see? And I just want to know, are you okay up to this point? Because what matters is to understand the work. Then we can go to the exercises because the exercises, we can even record them separate. You can even do them with the tutors. We can even do them before the exam. Just go all the exercises, all of them. But what matters is the exact, what's this? The concept. I grasping the concept now. Okay, so let's find
Yes.
dy dx. So they say dy over dx is equals to, can you please give me the formula very quickly?
Is equals to dy over d theta over dx over d theta.
Thank you. Now it means someone is going to do the dy over d theta. Someone else, let's find dy over d theta. Quickly, give me the derivative. Guys?
It's 3 open brackets.
3 open brackets.
Theta then becomes 1.
Thank you. Then?
And then sine theta is a cos theta, therefore it's minus cos theta.
Thank you. Next, dx over d theta. Different people? Guys, otherwise next discussion class, I'm creating a new link for the 3 people only. And I'm not accepting anyone else for the people who have answered. Because it's a discussion class. Let's discuss.
Is 3 into derivative of 1
Which is?
plus is 0
Yes.
plus derivative of cos theta is equals to is plus sine theta.
Sine theta. Thank you very much. Now, there's something you need to notice here. It's 3, 0 minus the derivative of cos theta is negative sine theta. If you didn't notice, so this negative times negative is plus. So this is sine theta. Thank you very much.
Ma'am, before you go any further, on the first one, the dy over d theta, I understand the second one. The first one, where you theta, the derivative of theta is 1. How did we come up with that one?
What is the derivative of x?
It's 1.
Remember, we said variable, meaning theta takes any value. When I explain the term variable, it's x, y, theta, beta, z, and whatsoever. So they take any variable. So look at theta as t instead of theta. So what is the derivative of t?
It's 1.
There we go. Because you don't know the value of theta in this case. Theta can take If it's an angle, say 20 degrees, 30 degrees, in this case, it's a variable, and therefore you're differentiating it. That's why it's 1 there. So if this was theta squared, then the derivative will be 2 theta. Are we together there?
Yes, ma'am.
You're welcome. Now, let's go and substitute dy over d theta. It's 3, 1 minus cos of theta, and then divided by dx over the theta, that's 3 sine of theta. We see this 3 cancels, so this is equals to 1 minus cos of theta over sine of theta. Now, taking you back to your school, high school, we say a plus b over c can be written as a over c plus b over c. But c, or maybe let's say d over a plus b, cannot be written as d over a plus d over b. Are we together? This is incorrect.
Yes, ma'am.
Thank you. So meaning that now we can write 1 over sine of theta minus cos over sine theta. What am I saying? Cos theta over sine theta. And what we have learned that 1 over sine theta is a reciprocal. The reciprocal of sine theta is actually what? Can someone remind me? 1 over sine theta. 1 over tan theta is equals to cot theta.
It's
1
cosec.
over, thank you, cosec of theta is it, and then this one is what?
Cot.
As tan theta.
Thank you, cot theta. Because cot theta is cos of theta over sine theta. I think this is the answer. Is this the answer? Yes, it's the answer. We are right. Well done to us. So dy over dx is equals to cosec of theta minus cot of this. Now, let's go to, so we have dy over dx. I don't know why it keeps on changing colors, this pen, when I change on the new page. So dy over dx is equals to cosec theta minus cot of theta. My heart is telling me to do something. And why am I not doing that something?
What is that, ma'am?
It wants me to differentiate. They want me to find d, the second derivative of dy with respect to x. And my heart is telling me to do something. Why am I not supposed to do that something? And why is it wrong?
We can't.
Because you have to.
Because
you cannot create the function of d theta on the function of dx.
Thank you very much. You see how maths is a language. Even when I speak silently, this side, you can understand me. Yeah, Nick. Okay. Thank you very much. Because you can't differentiate, and we're dealing with parametric equation. You can't differentiate like this. And with respect to x. Do you understand? Because we are dealing with parametric. We are dealing, guys, one day I might wake up and say, why? Listen to this. If I wake up and decide to do this. If I say y is equals to x cos of theta, and I say dy over dx, right?
Yes.
I'm not going to say that, but I'm just saying. And then you say this one is cos of theta, right?
Yes.
And then I say d squared over dx squared, and this is 0. Why am I allowed to do this? And there's a statement that I'm going to do, but give you, but why am I allowed to do this?
You are
And I tell you,
differentiating the x.
and I tell you that theta is equals to 45 degrees, but don't substitute it. Why am I doing this? Guys, me, I like you guys to think. It's because this was not given as a parametric equation. Do you see that?
Yes.
And they told you that theta is what? Is 45, meaning cos of theta will be some form of constant. That's why you are able to do this. Does it make sense?
Yes, ma'am.
Thank
Say
you.
now.
So don't confuse. Don't confuse me. I'll test your tricks as well. So it's very important. Here, the reason why you are saying now I have to do according to parametric, because initially you were given x is equals to whatever with theta, y is equals to whatever with theta. So let's do that. Let's do that. We know that this will be d. Okay, why am I having a highlighter now? It's too much excitement. Math makes me excited. So this will be dy over d theta over dx over d theta. And we do have dx over d theta. Can someone remind me?
Yes.
It was 3. Right?
Yes,
Thank
ma'am.
you. So let's go differentiate this. What was that, guys? Hey, it was something, but what was it?
We ended up with the negative cot.
Watch. Yeah, watch.
Ma'am, for dy d theta, don't you substitute the 3 minus 3 cos theta?
Oh, sorry. 3 minus 3 cos theta.
Yes.
No, guys, remember
No,
I said
no, ma'am. I
Oh,
mean
ma'am,
the dx
you wrote
over
it
the
incorrectly.
theta,
Sorry.
the derivative
the derivative. Thank you.
of the, yeah.
Thank you. Let's do that.
It's dx over the theta, ma'am.
Ma'am, in
Is it not
brackets, you
what?
must write dy over dx.
Okay.
Yes.
Or you're doing the
Yeah.
first.
Me, I'm tired, guys. You need to help me. Yeah. I teach you and I'm unteaching you same time. Thank you very much. I teach you and I will unteach you. So if you are not listening, I'm telling you, you see flames over dx. Thank you very much.
Yes.
So that is cosec of theta minus cot of theta. Don't say I didn't teach you this. Come on. What is the derivative of cosec? It's a funny derivative, but let's do it. You want me to tell you where it is? Oh, if I'm telling you, it means that you didn't do it.
The derivative of cosec is a minus cosec times cot.
Let me go copy. Minus cosec times
Cot.
Thank you. So the derivative is minus. That is page 2. Number 1, 2, 3 at the bottom, from the bottom going up. Started at the bottom, now we're here at 3. Thank you. So this will be equals to, yeah, now I'm tired. I'm seeing flames. So it's minus cosec of the inner function. Our inner function is theta, so that's theta, times the cot of our inner function, which is theta, times the derivative of theta, which is what? 1.
1.
Minus, what is the derivative of cot?
It's a minus cosec squared.
Minus cosec squared.
Now, be careful, bracket. There's a sign here. Trust me, if you see a negative, it means danger, danger. Protect yourself with a shield that is called a bracket. See a sign, guys, like sign like this, danger. Protect yourself. There's a shield. Cot minus cosec.
Minus cosec squared
Of the inner function, which is that one, times the derivative of the inner function, which is 1. So let's see, minus cosec of theta times cot of theta plus now cosec squared theta. Thank you. Oh, yeah, that was too much. Mouthful. So then d squared y over dx, the second derivative will be d of d theta dy over dx over dx over d theta. So this will be equals to minus cosec of theta times cot of theta minus plus cosec squared of theta. I hope you are watching so that when I do some magic, you correct me. So this is 3 sine of theta.
Sine of theta.
Are we all together there, good people?
Yes, 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 ma'am.
Now, hey, me if you leave it like this here, but then you can simplify it because you know that this. So let's do how they did in the textbook. They simplified it. So we know that this is minus cosec of theta times cot of theta plus cosec squared of theta times 1 over 3 times 1 over sine of theta. And we know 1 over sine of theta is what?
Cosec
of theta. Thank you. So this is equals to minus cosec of theta times cot of theta plus cosec squared theta times 1 over 3 times cosec squared theta. Now this cosec multiplied with that cosec is equals to minus cosec squared theta times cot theta plus cosec to the power of 3 theta times 1 over 3. 1 over 3. So this is equals to negative 1 over 3 cosec squared theta times cot theta plus 1 over 3 cosec theta. Are we together?
I was lost.
Where are you lost?
Oh, hey, the long expression. I don't know, but along the way, somewhere, I just missed the. Let me see.
Look at it. Look at it now, and then tell me where you're lost.
Okay. Is it? I get on the answer. I get it that the 1 over 3 you multiplied it all over inside, but why is it the first one? It have 1 over 3 cosec squared theta, but the second one is just only cot theta without the 1 over 3. What happened there?
Wait, because here it is the 1 over 3. This cot.
Yes.
It's a multiplication. Why would it have a 1 over 3? You remind me, 2 times xy is equals to 2xy, not 2x 2y. Make sense?
Okay. Yes.
I'm not happy with the okay. Okay. Because this is cosec times cot. Yes?
Can I ask a question before we go
Yes.
on? Like, we could have left the answer at minus cosec theta times cot theta plus cosec squared theta divided by 3 sine theta, right? But we went on to simplify it further. So my question is, I see that is done a lot on our study guide, right? So if we're writing an exam, is it okay if we leave it at that first answer without simplifying it further? Or depending on how many marks are located, then they will tell us whether we need to like simplify it further.
But you see here, you just substituted here. You just substituted. Yes. So you just leave it like that.
Yeah, but that's why I'm asking that, like, we just substituted It is also an correct answer, but we can take it a step further by simplifying it.
Thank you. You just answered as well, but we can take it a step further. If you can take it a step further, take it a step further.
Okay.
Do you understand? Because now you're saying, this is what I'm saying to you. So this is what you're saying. You say they ask you find the area and you know pi r squared, you know, isn't it? And then you go and find r is equals to 5. And then you say area is equals to pi 5 squared. And you leave it like that. You guys have to simplify. And when it comes to simplifying, we do mark those things with, you saw it's an identity, you saw it's a double angle, you saw it's, what do you call this thing? Sine of x plus b, y is equals to cos what? Do you see all those things? Then you saw, then you what? It's important that you simplify it.
Okay, ma'am.
Yeah. So that you get your full answer. What am I saying? Full answer. Full marks. Okay, any other question, guys? Any other question? Okay, so with masters, we did. I think I might do one example. My aim is that we cover the concept, and if you don't understand, you know, I'm here, send an email. And okay, see if we can do one last question.
Can we take one example from the activity, ma'am?
Yes, I'm taking an example. I'm taking an example.
Can I choose?
No, because I want you to go and do it, and then you, after that, if it gives you a problem, then we come back. Why do you want to choose the one that will give you a problem? Then I do your work. I want you to attempt it first. That's what I told Zintle last time.
I wanted to choose the simple one for myself, the one which I understand. I just want to see how you did it. You will do it.
Page what?
79.
29. Because I was going to do an example for accent first, and then we will come back. 79.
No problem.
79, page 79. Okay, you're choosing page 79. Which one?
Number 2.
Number 2. Okay. He's choosing page 79, number 2. I'm giving you, is it the one where if x is equals to cos to the power of 3 2 theta?
Yes, ma'am.
Yes.
Okay. How many minutes should I give you guys? We do it together. Remember, I told you you do it, I do it. So let's do, you do it, and then we come back. Let's do it together. Let me take a pen and a paper. How many minutes are we giving each other?
2.
2 minutes. Are you sure you'll be fine? You just learned it today. You just learned it now.
If we say 5, almost you're gonna be 5 minutes to 1, and you're gonna need to close the session. I don't know whether you're closing at 1 o'clock or what.
When I what?
Whether you're gonna be ending the session at 1 o'clock.
Okay, I'll give it an exception for today. Okay, number 2. So activity 1. I have a paper, so we can start. It means that at 12:55 we meet. That okay, right? 56 now, because you're not saying anything, guys. Is that okay?
Yes, ma'am.
That's fine.
Start. Are you done? Or you need extra few minutes?
Done, ma'am.
I need 3 dons.
Just 2 minutes, please.
58.
Done.
Done.
Guys, what's going on? Do you think you understand the work now when you try the question after the class?
Yes, ma'am.
I need 3 yeses, please.
Yes, ma'am.
Yes, ma'am.
Yes.
So do you think we can try it now? You'll get some marks, Nyan, for now because it's the first day.
Yes, ma'am.
Thank you.
Yes.
Then that's good. Let me go back to the question. Said page 79. Okay, let's compare our answers first. For my first answer, okay, let me not say my first answer. I don't want to embarrass myself. Your answer. This video will be this thing will be watched by my grandkids if they're going to do MAT2691. So so for the first one is dy over dx is equals to what? What did you get?
A minus 10 to theta.
Thank you. Minus 10 to theta. Did someone get something different?
Am I allowed to ask?
You are allowed. The discussion. You ask, you say, you comment, whatever. Yes?
Yeah, I ended somewhere there where I have 6 sine squared to theta multiplied by cos theta. Then the manipulation there. Can you just take me through that part?
I'll take you through after. But by next week, I hope you'll be fine. Okay.
Definitely.
Okay. So now, can I please get the answer for the? Why am I saying this? The second derivative of dy over dx.
The second derivative, I got 1/3 sec to the power 4 2 theta times cosec 2 theta.
Okay. It means I'm right if it's the same as someone. Yes, I'm right. I might be right. Let's do it together. You never know. Imagine the whole class having the same.
I hope they're not wrong.
I don't know as well. I got the same.
It's sec times cosec, ma'am.
Sec times cosec.
Yes.
Hey, why me and you are different here?
Ma'am, what did you do?
Let me write mine and feel embarrassed after. Hey, I shall sleep on the pillow of shame. Okay, I got why did I get this though? Okay, let me see. So then the derivative, I'll explain. So I got 1/3 cosec to the power of 4 theta times sine 2 theta. That's what I got.
Okay,
But
ma'am. With mine, it's a 3 sec 4, not cosec. It's sec.
Yours is sec 4.
Yes, sec 4 times cosec.
Okay, maybe it's a simplification. You never know. You know, maths has so many ways. Let's not kill cats, but so many ways of killing a cat. Squared over dx squared equals, you got 1/3.
3 sec to the power 4 2 theta times cosec 2 theta.
And cosec times cosec.
Yes, cosec.
Okay, here it's 2 theta for me as well. So I got 1/3 sec to the power 4 2 theta times sine 2 theta. Yours might be wrong. You know why I'm saying that? By just looking at it. It's because when you, yours is this one.
The sec. Okay, yes.
Okay, here is 2 sine theta. I think mine might be correct. Okay, now we don't know which one is correct, but because comparing to which one is close to correct, I think mine is close to correct. The reason being, the reason why I'm saying, guys, sometimes it's easy to see that something might be wrong. You know why I'm saying that it might be wrong, ne? It's because your denominator is a sec.
My denominator has a sec.
Yes, your denominator is a sec. Has a sec.
Yes.
Right? And when you differentiate, has a sec to the power 4. And when you differentiate this you will have, this is where you get your sec, isn't it?
Yes.
But your sec will be on top. How did it come at the denominator?
My sec.
I don't know if you see what I'm saying.
Okay, ma'am. You see. Let me explain to you,
hello,
right?
ma'am.
Yes, I hear you guys.
Okay, so with that minus 10 2 theta, right? when we differentiate it, we get the sec that you're talking about, the sec squared 2 theta, right? And it's on top, right? And then remember, we need to divide. We need to divide that when you're getting the second derivative. We need to divide that with our dy d theta, right?
dy. You're dividing dy. Fix that.
No, she's trying
dx.
to say
Sorry, dx.
It's over.
Thank you. Thank you.
dx. Yes. So when we're dividing with the dx, right? So from the divide, I times my sec squared with so it's with my 1 over cos squared 2 theta times sine 2 theta, right? And then our one cos our cos squared 2 theta is the same, isn't it the same as a sec squared 2 theta? Okay, write it down for you to understand me, right? So we are going to do it like this.
Yes.
Okay.
Okay, maybe let's do the first part and then we'll discuss the second part.
Okay.
Yeah. No.
So I start from dy.
Wait, let me fix mine. So this is 1 cosec theta of that over that. So if this is okay, I think now I fixed mine as well. Hey, yeah. Okay. So mine is 1 over, still it's different from yours. I'm just trying to fix it by looking at it. So this will be 3 cos squared 2 theta times sine squared theta.
Why
That's
3,
mine.
ma'am? Because it's 6.
Let's do it now. Let's do it now together. Let's do it together. Then we can discuss. Okay? X is equals to what? Please tell me.
It's cos to the power 3 2 theta.
So it's cos to the power 3 2 theta, isn't it? Y is equals to what?
Sine to the power 3 2 theta.
Right? So now, I always find the derivative with respect to it, because at the end of the day, whatever questions they'll ask us to do. So let's find dx over d theta. What is it? Dx over d theta, what is it? Guys?
It's 3 times.
Minus 6.
Oh.
Yeah, give me the answer. Isn't that now we know how to differentiate now?
Oh, okay.
Minus 6.
Minus 6.
Cos squared 2 theta.
Cos squared 2 theta.
Sine 2 theta.
Times sine 2 theta. So it means here, that's a mark. It's also the same as mine. Come, let's go ngapha. So dy over d theta is equals to
6 sine squared 2 theta.
Sine squared 2 theta
Cos
times, thank you, 2 theta. Mark, okay. Dy over dx. How do I find dy over dx?
We say 6 sine squared 2 theta.
Formula first, remember. Dy over d theta divided by dx over d theta. So this is equals to what? 6 sine squared 2 theta times cos 2 theta over minus 6 cos squared 2 theta times sine 2 theta. Are we together there, guys?
Yes, ma'am.
Yes.
So I heard someone said they couldn't simplify up to here, from here.
Oh, yeah, I'm sorted, ma'am. It's on that part, the other one, where we have 1 over that long expression. Yeah, I'm
Okay, no
sorted.
problem. No problem. So here, how do we simplify? We see there's a 6 here, right? And then, so we have a 6 and a 6 will form a 1 or cancel what they were saying in high school. So you this one and this one, right? Do you see that? Are we
Yes,
all
ma'am.
together? But there's
Yes,
a negative sign there. So the negative sign, let's put it here. Let's not forget this negative sign, We put it there. They form a 1, isn't it? That 1. Okay, times. Here, do you see that we have sine squared 2 theta and sine squared? So we have sine squared 2 theta over sine squared.
Great, yes.
I mean sine 2 theta. Do you see that? We are allowed to do that because if we have A times B times C over x1 times x2 times x3, because it's only multiplication, we are allowed to say A over x2 times B over x1 times C over x3. We're allowed to do that. So this is multiplication. That's why we're allowed to, we can even separate them like that. So now, you see here, there's a sine squared 2x. So basically, we have x squared over x. That's what we have, something similar like that. So that will be what? X squared over x is what?
X.
Thank you, x. So meaning that this will be equals to what?
Sine.
Sine
2x. 2 theta.
2 theta. Thank you. And it's at the top, isn't it?
Yes.
Thank you. So one can say, let me write it here. One can say there's so same base, same bases you are dividing, you subtract the exponent. So it will be this one will cancel one of that. Or let me write it like this. Yeah, you know, when you're tired, you don't even think. So the negative, we agree with the negative, isn't it here?
Yes.
And we say this 6 and this 6, they move, they cancel out. Let's say go back to our grade something, right? So let's write. So then we have sine 2 theta times sine 2 theta. Do we agree that sine squared theta is the same as sine 2 theta times sine 2 theta?
Yes, ma'am.
Cos 2 theta. And then here we have cos 2 theta times cos 2 theta times this sine 2 theta. Now going back to what you were cancelling all along. So this one and this one cancels that one or forms a 1. That one cancels that one. Just trying to simplify it. So then we have a negative. We're left with this one, sine 2 theta over cos 2 theta. And we know that according to what we have learned, this is minus tan 2 theta. Therefore, dy over dx is equals to minus tan 2 theta. Are we all together there?
Yes, ma'am.
Thank you. Now I'm sweating. So let's go. Dy over dx is equals to minus tan 2 theta, right? So now, why am I sweating? I know why I'm sweating. The second derivative, x squared is equal over dy over dx over dx over dy. I'm being speechless now. I don't know. Okay, so let's find this top part. Me, I like saying sometimes if you don't want to substitute it immediately, let's do it separately. So let's find this top part here. This top part here. So this will be d over d theta, dy over dx. So d over d theta minus tan what? Tan 2 theta, isn't it? I'm not teaching you how to find the derivative of tan theta.
Yes.
You know how to find the derivative. It's on page something. I think it's page 2 or whatever, there at the back. So give me the answer, please. Guys,
It's
It's
what
a
is the
minus
answer?
2 sec squared 2 theta.
Sec squared 2 theta. Something is missing there.
a
It's a
2.
2.
Thank you. Times the 2. So this is equals to minus 2 sec squared 2 theta. Are we all together there?
Yes,
Yes.
ma'am.
Yes.
Thank you. So let's take this. So d squared of dx squared is equals to d over d theta of dy over dx over dx over d theta. And we know dx over d theta is equals to what? Please remind me.
Minus 6 cos
So it's,
squared.
yes.
Minus 6 cos squared 2 theta multiplied by sine 2 theta.
Thank you. I have to confirm because what I wrote in my book might be wrong, but I know we are right together. When I'm alone, I'm wrong, but when we are together, we are right. Imagine. We should sing that song. Squared 2 theta over. This is way. Cos squared 2 theta times sine 2 theta. Okay. This is where we're debating, isn't it?
Yes,
Yes.
ma'am.
Hey. Okay. Now I'm sweating. Forgive me, my great-grandchildren. I was forced to write this in 5 minutes. So this is what I got. So it's 3 cos to the power of 4 2 theta times sine 2 theta. Second answer, you said you got
1 over 3.
1 over 3.
Ma'am, it's not all, it's just 1 over 3.
Okay. I hope it's not changing because now we are seeing the answer.
No, it's not changing. It's not changing. Sec to the power 4.
Sec to the power of 4.
2 theta.
2 theta.
Multiplied by cosec 2 theta.
You might be right, actually. These two are right. I'll tell you why. But I thought you say 1 over 3.
No, ma'am. No, ma'am.
Okay. Let's see. Yo, the beauty of math. It'll make you burn. Yo. Okay, where do I start? Okay, let me start here. Yo, hi, Shem. Oh, what are you doing to me? Okay, d squared y. You know when you bet on lottery and numbers are coming, you're like, yo, I wish my answer comes. I wish this is what I'm feeling. But it looks like both of them might be correct, and let me explain why. Okay, let's start here. You see this, there's this and this, they divide each other. Do you agree there?
Yes.
Yes, ma'am.
Right?
Yes.
So there is 1. Okay, I'll do the way I did it. So that is 1. So 1 over 3 times. So we're left with sec squared 2 theta over cos squared 2 theta times sine 2 theta, isn't it?
Yes, ma'am.
Now, what is sec theta? 2 theta equals to? Guys, what is sec theta equals to?
It's
1 over
cos 2.
Thank
theta.
you. 1 over cos 2 theta. So this is equals to 1 over 3 times 1 over cos 2 theta times.
Sorry, ma'am.
Yes.
The square.
But that one is the sec squared. It's not sec 2 theta.
Oh, sorry.
It's sec squared.
Now you are embarrassing me.
Oh, my apology, ma'am.
Hey, Okay, let's come back. Hey, Matthew. So this is 1/3, right? Times. So this is 1 over cos squared 2 theta. Are we all together?
Yes, ma'am.
Good. I might be wrong here. So let me see. So this is then cos squared 2 theta times sine 2 theta. Are we all together there?
Yes, ma'am.
Now I want to do it baby steps. Baby steps. So let's choose another color, green. Let's do this part here. So we know that this is 1 over cos squared theta divided by cos squared 2 theta. Guys, I forget the 2 theta, sorry. Times sine squared 2 theta. Are we together?
Yes.
Right?
The sign is not squared, ma'am.
Okay, still, let's write it then. Thank you. I'm shaking here. You won't see it. Sine
Don't shake.
2 theta. Are we together there?
Yeah.
Okay, let me not feed you what I think. Let's help me to simplify, because if I feed you, I'll push you to get my answer. What do we do after here?
Then it's 1 over cos squared 2 theta multiplied by 1 over cos squared 2 theta sine theta 2 theta.
So this is equals to
1 over cos
yes
4 2 theta sine 2
times.
theta sine 2 theta. Then
Let's take
we
it
still have
back.
the 1/3 there that is outside the bracket.
Okay. 1
over 3
times that, isn't it? So that will be I just saved my generation from embarrassment. I want to thank myself. Woo! Okay, it's right. Let's see the other one. The reason why I'm saying it might look right, it's because what the lady did is what I'm assuming she did now. Thank you very much to myself. Woo, yeah, guys, you don't know. I was shaking inside. Doing these problems in 5 minutes. Hey. Okay, so this is what I think you did, and it's also correct. That's why when we're marking, we look at your questions with the microscope. We look at your answers with the microscope. Is it telescope, microscope? Yeah, microscope. That thing, like this. That thing. Yeah.
Even from your answer, we can get my answer.
Yes. So yeah, that's true. That's true. You're right, actually.
Yes.
Yeah, you're right. Because okay, so this is what you said, right? You're saying, okay, there's a sec there, so that is 1/3, right? Times sec squared 2 theta, isn't it? That's what you said. Times 1 over cos squared 2 theta times sine 2 theta.
Oh yes, ma'am.
Right? So because we said we can do, we know that 1 over a times b is the same as 1 over a times 1 over b, right? So in maths, we are allowed. So then this will be equals to 1/3 sec squared 2 theta times 1 over cos squared 2 theta times 1 over sine 2 theta. Are we together there, guys?
Yes, ma'am.
Yes, ma'am.
Yes. And we know that 1 over sine theta is equals to what?
A cosec.
cosec theta. Thank you. And then 1 over cos theta is equals to sec theta. So meaning that this will be equals to 1 over 3 sec squared 2 theta. Guys, don't be confused. What's this? If this is squared, this just means this is also squared. If this is squared, this just means this is also squared. If there's a 2 theta in here, it means there's a 2 theta there, right? So this will be sec squared 2 theta times, what's this?
Cosec.
Cosec, thank you, cosec squared 2 theta. Is it cosec squared? No, it's cosec, is it? Yeah, cosec only.
Yes.
Yeah.
Only cosec.
So this is 1 over 3. So this sec and the sec, they make 4 2 theta times cosec 2 theta. So this answer is the same as that answer. Oh, both of us have saved our generations. Oh, okay. Oh, that was adrenaline. It was so nice. I just drank 7 coffees at once. Okay, no. I think it's too much. I think we are fine. We can stop the recording. Any question?
Ma'am, I have a question regarding